invite the third presentation, Florian Maurer. The work called the market abstraction of energy markets and policies, application agent-based modeling toolbox. So, Florian, the floor is yours.
Yeah, so hello and welcome to my talk about my paper with the title Market Abstraction and Energy Markets and Policies with an application in agent-based modeling Toolbox. And I wrote that paper with a few other researchers from Germany, from other institutes in KIT Karlsruhe and also from Freiburg. Yeah, and of course with my supervisors. First of all, in the recent years, we have seen that the energy markets were a lot in the media, and especially as the prices were rising, a lot of discussion has happened according to the best market design, which is needed to fit our energy markets in Europe. But it was also a discussion in other countries, and also in Brasilia, we had a recent change to the market design. So energy market regulation is a very opinionated topic, but how do we know if we have the correct rule set? So recently, we normally have a development cycle where we see that there's a problem, then we try to find a market reform to solve that problem, and then evaluate what the reform impact is of that. And after a re-evaluation, we are getting on to the next market reform, which covers latest changes or latest challenges of our energy markets. But it would be much better if we had like a way to not test that in the real world, but just add a new software simulation to that, which can give us insights of what a better market design would be, or if we are going into the right direction beforehand. And as this can't be really solved with a centralized optimization, because in reality, the behavior of each market participant differs from the optimal behavior or the optimal solution. I'm also using an agent-based simulation for that and hope that software can help here in the future. But to find a simulation of different market designs, we first need to define what is a market design, and then we need to find an abstraction so that we can simulate and represent a market design in software. So after watching and looking at a lot of related work and also ontologies from Portugal with Mashem and also other energy market simulations, I came to the conclusion that a market design can be defined as a sum of all possible trading options, including subventions, promotions, customized incentives through policies, and its participants and their allowance to the market. So a market design can also contain multiple markets, as it is often the case. But in recent market simulations, often only one market was focused at. But we need to take other cases also into consideration. So if we want to simulate such a market design, we need to find a definition of that in software. Let's look at the first few examples of how such a market design can happen to get a better idea of that. This is like the typical energy market, which is simulated in most of the energy market simulation tools, which is like an hourly product for the next hour. After that, it's cleared with uniform pricing or pay as clear, and then the next hour is cleared. This is a simplification, and even if we only look at the day-ahead market, in reality, it's much more complex. We have 24-hour products and have a clearing once a day. So if we would want to simulate that, we had to make our agents behave that they find a strategy not only for the next hour, but they need to find something for the next 24 hours and eventually take ramping and other things into constraint. But still, our actual market design is much more complex. For example, we have multiple markets where on one market we have a long-term bidding. In this example, we have 7-day products and a clearing every week for this whole period of 7 days, like you can imagine it as a base load. And of course, we have some kind of day-ahead market, as I have shown on the first example with the energy-only market, where we have an hourly product with our hourly market clearing with uniform pricing. So here we have multiple markets which have to be simulated, even though they have different time constraints and opening and closing of their energy markets. But in reality, most of the actual trading doesn't happen on one of the regulated markets, but more than about 60% are traded through over-the-counter trading or bilateral contracts. And this isn't taken into consideration in most of the energy market simulations, but I also want to be able to tackle this. So we have like a third market in our market design here, which can tackle yearly contracts with a yearly auction. And also the other markets, like our long-term market is now the EEX futures market, which is also much more complex because it has multiple different products. So you can trade for each of the next 7 days. You can trade for the next whole month as a baseline, also, or you can trade for the whole year as a baseline. And also our day-ahead market has multiple products for an hourly product, a half-hourly product, and the quarterly hourly products, which makes things much more complex because you then need to find a strategy on which market you would trade which amount. But we are not here, and we are not yet at the trading part, or at the bidding part of the participants, but only focusing currently on how to model the market itself. After looking at a few examples, I then came to find an abstraction of energy markets, which allows me to model all of the given cases and can be used to simulate other markets which you can imagine too. Therefore, I created like an option to define different market products as a list of market products which can be traded as a market as one example. And I can also define like opening hours. They can be defined as a recurrent rule, which is something you might know from your Outlook calendar, as you can specify when a market opens and closes, as these times are sometimes also very advanced. For example, opening every day at 8 o'clock and closing at 18 o'clock, but not on the weekend. And I also wanted to respect that. So I added a very sufficient solution to that. And also you can define different market mechanisms. For example, we had the pay as clear, the uniform pricing, but on other markets we have pay as bid, so where you directly pay the amount of your bid and not the uniform pricing at the clearing which took place. But there are also other market clearing mechanisms which take the grid consideration into respect the grid considerations, as we have nodal pricing in America, in North America, and also can imagine other types of new market mechanisms in the future. And to extend this market configuration to future markets we can imagine, we also have the possibility to add additional fields to extend this baseline, which can be seen as like the common ground which each market has. And through these additional fields, we can also add things like a block ID for block bids or exclusive orders or the like, as we have some funny kind of blocks or bids in various markets in Europe too. So then I looked at a scenario which I wanted to showcase to show that you can actually compare different energy market designs through our market tool. And I selected two small examples for that, which is on the left-hand side, the small energy-only market we had on the first, as a first example. And on the right-hand side, you can see the second scenario, which also includes a long-term market, which has a pay-as-bid, while the energy-only market is using pay-as-clear, or uniform pricing, as it's also often called. And the long-term market has like the 7-day schedule, and the energy-only market here is using hourly bids. And after simulating that with a small setup with 4 different power plants and bidding agents, and each of these bidding agents was just bidding their marginal price. So I didn't want to put a lot of effort into that and also have this example understandable. I can now see that the results are can be seen, and you can actually compare these. But of course, you can see that on the upper graph, the total dispatch per market is much higher in the energy-only market in scenario 1, because we have the uniform pricing over all of our market, which was all of our amount which was traded at this market. While, as we said, on the long-term market, we have pay-as-bid. We get away a lot cheaper because we are not using the uniform pricing. But of course, this is not applicable to reality, because in the real world, you wouldn't bid your marginal costs on a market which has pay-as-bid as a pricing scheme. So this can only be shown to make clear what the capability of this market tool is, and that you can simulate and compare different energy market designs, but I wouldn't take that as advice. So in the future, I want to simulate much more of the existing real-world markets, which we have around the world, and also use these to simulate the energy systems in some different countries. I'm currently, of course, doing that for Germany, and I also want to integrate other market mechanisms, which include nodal prices or security constraint unit commitment. And sometimes I also want to look at the stochastical optimization here in Brazil. But currently I have other papers which I want to publish. And the other part is like, how can we get a sufficiently complex agent behavior of our bidding agents? And fortunately, there are other researchers in my group which tackle this with the use of reinforcement learning, as AI is always one of the high topics we have. And there will be also some bidding strategies which are a lot more easy to understand and use optimization approaches, which we already have. And here on the right, you can see an example where we also have economic evaluations, and you can see the cash flow, the production cost, and the profit from that for each agent of this energy market simulation. So that's it for my market simulation. Thank you for your attention. You can find it on GitHub, and that's also my GitHub and mail address.
Okay, thank you for the nice presentation, Florian. Now you are open for questions.
Yes, thank you very much. And just first of all, we have one PhD student going to submit his PhD thesis on 15th of December. And maybe you can have a look at his PhD after public available. And I have basically 2 questions. The one question actually is, have you looked at, because in the electricity market design domain, actually there's quite lots of theories about market design theories. Have you looked at it and which one you applied? This is my first question. The second of all is the agent behavior. Is you only consider about bidding agent or any other, because you mentioned about the participants. So what participants you refer to, and are they the agents? I mean, basically, what type of agents in your simulation?
So I also looked into different market design. So first of all, I think the definition of a market design was very vague, and it wasn't defined in a lot of places I found. And therefore, I also first came up with a definition of that. But in market theory, there are, of course, different optimizations and findings how one can improve the market, which I also want to take into consideration. Something is like VCG auctions, so Wiki Crack Grooves auctions, which I also wanted to implement once because they seem to be a little more complex, but also give a better result of the energy market. And but I would also like to discuss that with you. And on your second question, so in my scenario I had here, I have each participant is someone who bids on the market. So this can be constrained like from the market, so that, for example, only renewables can bid there. But here we had one power plant which bids its amount of energy. But you can also define like that one operator is the bidding agent on the market, and the operator has multiple power plants, so that he also needs to do portfolio optimization, which is also a problem which is very common in these market simulations. So that's a variety of other things. And in the future, there will also be a grid operator as a separate agent who then can communicate with the market too.
Okay, the next question.
Thank you for a very, very nice presentation. Basically, I have two questions as well. The first question is, you mentioned this about nodal pricing versus area pricing. Do I have any? Yeah, you also mentioned that's probably future work, so if you're not able to answer what's best and why, so you just leave it. But and then another question is, which somehow links to that. I guess some of the markets in scenario 3, 4, whatever, would be focusing also on the low level, the low level issues and so on, because the voltage in the future, I think many of the challenges will not be to keep the frequency can be solved in many ways, but the problem will be more to keep the transformer temperatures below some levels on the distribution level and the voltage along the feeder. And so I think you need low voltage or more local markets. Don't you think so? Or, yeah, that's the question.
So that's also something I wanted to take into consideration, like local energy markets. And also, there are, except for like the product of energy itself, there are other markets which have trade capacity, and also the view on control reserve, and these kind of markets are also very important and can be simulated in the future. So I created this market abstraction so that it can also be adapted to that. And of course, someday in the future, I want to also have like a real-world market simulation, which also takes all these things into consideration. Yeah, I think so too. I think I need a few other PhDs who are coming after me.
Okay, Professor Ball.
Thank you. I was wondering, have you made an ontology for the market?
If you think of an ontology like the things which were created in Mashem, I didn't do that. So basically, the definitions I used here, they are like kind of an ontology, but it's not an ontology in the way as it is defined through one of the ontology languages. But I thought about that, but then I somehow wanted to get going because I had the feeling that the ontologies or creating the ontology is also a lot of work, which would then hinder me from doing other progress. But I would also be very open to.
It was just because it seems that you want to allow the user of your simulation to dynamically generate different markets.
Yeah.
So basically give this dynamic combinations.
Yeah.
So I think you need to have an ontology to guide what would be the correct or feasible, allowable combinations to do that fit with the rest of the ecosystem.
But
just to make sure that you simulate something that are feasible.
Yes, somehow I think that this will be solved by having documentation on the framework, which is already available also, as you can see on GitHub. And there I want to describe what is possible and what is not possible. But I think the ontology part would be much better to make sure that another software can also be connected to that. And I also have some approaches to this, as the simulation tool we are using is also using ACL messages, which is also something which can be used to have agent-based communication between multi-agents. But there's currently no ontology.